So for section 2.6, we are going to talk about radioactive decay and half-lives. Right? So, what is a half-life? A half-life basically tells you that if we have a given amount of something, how long the half-life is how long it takes for half the original amount to decay. Half-lives, depending on the isotope, are all over the place. Okay, just to give you an example of, they can be down to fractions of seconds, they can be billions of years. Just a couple examples. So table 2.8 in your textbook has the half-lives of a bunch of different radioactive isotopes, but basically just to give you a few examples of things that we've talked about, technetium 99M is 6.0 hours. Carbon 14 is 5,730 years, and uranium 238 is 4.5 billion years. All right. Now, there is no way for you to know these. These have to be provided to you unless you're given enough information to find them, which we will talk about. But let's do some calculations with finding these. All right. Here's how a problem like this would typically be phrased. Okay, so let's say that I have 724 micrograms of carbon 14. I want to know how much remains after 3,500 years. Right. So to do this, I'm going to use a couple of equations. First thing I'm going to do is I'm going to find how many half-lives we've gone through. Now, to do that, I need to divide time passed by the half-life. All right. Time passed divided by the half-life. Okay. Now, we know, I gave this to you on the previous page. I realize it's not written here. Again, this would be provided to you. Half-life of carbon 14 is 5,730 years. Okay. So I can take 3,500. By the way, I'm going to call this N. That's our number of half-lives. So I'm going to take 3,500 years, divide it by 5,730 years. And if I were to divide that out, I would get 0.611, which is equal to N. Now, if I want to find out how much remaining, I'm going to use this equation. Amount remaining is equal to initial amount times 0.5 raised to the power of N. Right? Amount remaining is equal to the initial amount raised to the power of N. All right. So to set this up, I'm going to say amount remain is equal to 724 micrograms times 0.5 raised to the power of 0.611. That's going to be equal to 724 micrograms times 0.654, which means my amount remaining is equal to 473 micrograms. Right. So let's flip this around. And let's say that I tell you about some hypothetical substance. Whatever that substance is, doesn't really matter. Let's say that I know I started with 152 milligrams of it. And after 523 years have passed, I have 34.2 milligrams, right? So, and I want to know, what is the half-life? Here's how we can do that. So first of all, let's just plug what we have into this equation. We have our amount remaining, which is 34.2 milligrams, and that equals 34.2 milligrams is equal to 152 milligrams times 0.5 raised to the power of n. So the only thing we don't know here is n. All right, let's take both sides, divide it by 152, and we are going to get 0.225 is equal to 0.5 raised to the power of n. All right, how do we get rid of this 0.5 and so that we can get n by itself? Right, the way that we do that is we take the base 0.5 log of both sides. Log base 0.5 of 0.225 is equal to log base 0.5 of 0.5 to the n. Now, your calculator may or may not have, I guarantee you it doesn't have a log base 0.5 button on it. It may have a log base n button on it, or it may not. So if you have that, the way you can, if you don't have that, the way you can plug this into your calculators, you can just hit log of 0.225 divided by log of 0.5. That's base 10 log if that's the option you're given. And then we would do the same over here. Whole point being the log base 0.5 of 0.5 is 1. So that basically just makes this 0.5 go away. But anyway, we do this and we are going to get that 2.15 is equal to n. Now, let's go back and let's look at our equation that we use to calculate n. N is equal to time passed divided by our half-life. Right? Time passed divided by our half-life. We abbreviate half-life as T1 half, by the way. So if we rearrange this, we get that time passed, which we have, divided by n, which we just calculated, is equal to T1 half. So we can take So we can take, sorry, I didn't write this down. We can take, or I didn't write down these steps explicitly. 523 years divided by 2.15, and that is going to give us that we have a half-life of 243.3 years. All right, so that's how we do that.